This lesson is going to help us understand how molecules behave in terms of their speed and their temperature. So let's go ahead and look at, we're going to pump in some gas here. You have the blue one right there. And I'm going to heat this up a bit. Okay, there you go. So now we're at 331 Kelvin. Okay, so you can see the speed of the molecules right now. I'm going to go ahead and make it smaller so you can see it easily. Okay, so what I'm going to do is I'm going to heat this up, and please observe the speed of the molecules. So as you can see, as it gets hotter and hotter, the molecules go faster and faster. So what I'm going to do here on this side is going to show you something called Boltzmann's distribution. Boltzmann is the name of the scientist, and the distribution tells you the relationship between the number of molecules and their speed. When it was cold, they're a little bit slow. Okay, so their average speed is around here. Okay, so this is when they're cold. So this is the velocity, let's say 10 miles per hour. Okay, let's say this is, let's say meters per second. It doesn't matter, it's just the velocity. What this means is the average velocity is about 10. Some of them are going faster and slower, but on average it's 10. Okay, and the reason why some of them are going faster and slower is because some of the energy that's not shown here goes into the vibrational motion of the molecule and also rotational, not just, what you're seeing here is the translational motion. Vibration, I showed you before in the video where the molecules can wag, move back and forth, or move end to end. Okay, so what I'm going to do now is when I heat this up, as you can see, the molecules went faster. So we're going to draw a little graph here. So a little bit faster to where the average speed is now 20 meters per second. This is hot. Okay, again, this is the same number of molecules. So if you had 25 molecules in here, you still have the same 25 molecules. But now the reason it has a distribution is because, again, going into the vibrational and rotational motion. So bottom line, when it's cold, they're slow. The average velocity is slow. When they're hot, the average velocity is high or fast. Okay? What I'm going to do next is introduce some other molecules in there. So let's go over here. So we're going to do the hot. We're going to do the hot temperature right here. Okay? And right now the average velocity is 20 meters per second. Okay? So this is hot. And this is the blue molecules. Let's say the blue molecules are, let's say it's ammonia. Okay, ammonia is a gas. And what I'm going to do next is add in some molecules. I'm going to add in the smaller molecules here. So, oops, still blue. There you go. Okay, what do you notice about the speed of the smaller molecules? Yes, you can tell that they're moving faster, okay? But they're the same temperature, right? So I thought that the velocity is due to the temperature. It's due to the temperature, but it's also based on the mass. So it seems like the lighter the molecules are, the faster they go. Okay, so I'm going to draw that here. This is the initial one. Remember, this is the hot temperature, right? I'm not changing the temperature. 1,459 Kelvin. The temperature is the same for the red molecules, but it's moving faster. So the average velocity is going to be faster. Let's say 30 meters per second. Okay, so this is still hot, same temperature, but instead of NH3, it's a smaller molecule. Let's say it's helium. Helium is just one atom. Okay, notice helium is really light. and ammonia is very heavy. Okay, helium has a mass of 4 grams per mole, about 4 grams per mole, and ammonia has a mass of, this is 14, about 17 grams per mole. So what we can see from this is that if the molecule is heavy, like ammonia, it will be slow. If the molecule is light, it will be fast. Okay, and this is Graham's law. Graham's law states that the mass is proportional to the velocity. Specifically, if mass goes up, it's very heavy, it slows down, the velocity goes down. So the relationship is inverse. As mass goes up, the velocity goes down. As it gets heavy, it gets slower. Okay, in the next video, I will derive for you Graham's law.